Good evening, everyone. Good evening and welcome. Oh, well, thank you. And with this, I conclude tonight's event. Thank you all. No. My name is Bill Maurer. For those of you who don't know me, I'm delighted that you're all here this evening for what's going to be an absolutely fascinating conversation at the intersection of science and spirituality with our fantastic guest, Professor Don Hoffman from Cognitive Sciences, and Deepak Chopra, who is known to many of you. But I wanted to say a few words before I invite the Chancellor to come up to the stage to introduce our speakers and welcome you also formally to UC Irvine. This is the second time in the past year that we've had the privilege of having Professor Hoffman and Deepak Chopra together for a UC Irvine event. The first time was this past fall in New York City at a gathering of some of our social sciences alums at Marlin and Associates, first for a kind of intimate salon and reception, and then for a book signing and talk at the Rubin Museum of Art. And I really, really want to thank Don and Deepak for doing this here at Irvine, on the Irvine campus, for those of us in Orange County to enjoy. I also want to thank my generous and talented co-host for the evening, Jennifer Hill, who's here in the front. You'll meet her in a second. She and I will be moderating the discussion. She's from the class of 2002 and also a generous supporter of the UCI School of Social Sciences Dean's Leadership Society, many of whose members are here in the audience tonight. The DLS is an incredible support organization of our alums and community members and others who are interested in what we're doing here in the School of Social Sciences, and it's because of them that we're able to host events like this evening. And this evening's discussion really gives you just a kind of small window into all of the things that are going on here at UCI and in the School of Social Sciences in particular, from Professor Hoffman's own work in cognitive science to my work in cultural anthropology to people in Chicano Latino studies. We cover the breadth of the human experience in all of its dimensions and at every scale, from the micro to the macro. And we are also a place that is quite proud to be advancing UC Irvine's broader mission of advancing the American dream for all of our students. As the largest academic unit on the campus with the most diverse student body, we have created and we support the programs around the campus for first-gen students and underrepresented students from a variety of backgrounds so they can succeed here at our university. I now would like to welcome to the stage UC Irvine's Chancellor, Howard Gilman, an award-winning scholar and teacher with expertise in the American Constitution and the Supreme Court, and multiple appointments across the campus, which I won't list, but also who serves as the co-chair of an incredibly important UC system-wide enterprise, the University of California National Center for Free Speech and Civic Engagement. Chancellor Gilman.
Thank you, Bill. Let's hear it one more time for Bill, our fearless leader, Bill. Bill, I think I remember, correct me if I'm wrong, are you actually the first dean that I appointed when I first arrived here? Okay, good decision, right? I started off strong. I'm not sure I can keep it up, but I'm doing the best I can. So good evening, everyone, and on behalf of the entire UCI community, it is my tremendous pleasure to welcome you back to UCI. I'm very grateful that you are all here, but I want to extend special recognition to our wonderful UCI trustees, to the Chief Executive Roundtable members who are here tonight, but especially to the School of Social Sciences Dean's Leadership Society, who are doing such important work on behalf of this tremendous and vitally important mission. I know that Michelle Williams and John have done fantastic work helping lead this work. If you are a member of the Dean's Leadership Society, will you just rise and be recognized by everyone here for your efforts? Thank you so much. We're very, very grateful. Chancellors get a lot of attention, but if you want to know who's really making the university move forward, it's fantastic deans working with their great students, faculty, and staff on vitally important projects. So thank you for your support for the dean and for the mission of the school. So one way of thinking about a university is that it is a place where conversations happen about reality and fundamental values, about something that we hope approximates truth. And if that is one good way of describing our role, then tonight's wonderful program is one great way to fulfill that mission. It is my great pleasure and honor to introduce our spectacular speakers and co-moderators this evening. Don Hoffman is a professor of cognitive sciences here at UCI. With a joint appointment in the Department of Logic and Philosophy of Science, he has received the Trollin Award of the National Academy of Sciences, a Distinguished Scientific Award of the American Psychological Association, and the Rustam Roy Award of the Chopra Foundation. His writing has appeared in Scientific American and Edge, and his work has been featured widely in publications such as The Atlantic, Wired, and Quanta. His 2015 TED Talk, "Do We See Reality as It Is?" has been viewed more than 2.6 million times, lays out the premise of his latest book, The Case Against Reality, which he'll be discussing tonight. After the event, we should ask Don whether what we just saw was real. Deepak Chopra, of course, founder of the Chopra Foundation, which conducts research on well-being and humanitarianism, and Chopra Global, a modern-day health company at the intersection of science and spirituality, is a world-renowned pioneer in integrative medicine and personal transformation. Dr. Chopra is a clinical professor of family medicine and public health at the University of California, San Diego, a very fine institution, if I do say so myself. He is the author of 90 books, including his most recent one, the national bestseller, Metahuman, Unleashing Your Infinite Potential, which is the focus of his comments this evening. Time magazine has described Dr. Chopra as one of the top 100 heroes and icons of the century. And so if you are feeling good about your accomplishments, it's time to readjust your expectations. Co-moderating tonight's discussion are Bill Maurer and Jennifer Hill. Bill, of course, is Dean of the fantastic School of Social Sciences, my dean, as a matter of fact. His most recent publication is a 6-volume series, A Cultural History of Money, covering money and its technologies from antiquity to the present day. Among other honors, he is a fellow of the American Association for the Advancement of Science. And finally, Jennifer K. Hill is co-founder of the business consulting firm MetaBizics, which is now also a TV show. She has appeared on many major news outlets around the world, including BBC News, ABC, NBC, and Fox. In 2010, she opened a legal recruiting company, which was later acquired by Markham Search LLC. In 2013, Ms. Hill published her book, Stop Hoping, Start Hunting, A Job Seeker's Guide to Finding a Dream Job. She hosts a weekly radio show on LA Talk Radio called Get Yourself the Job, and recently sponsored and built 2 schools in third world countries. Folks, we are all in for such a treat. Will you please join me in welcoming all of these fabulous panelists to the stage?
Wonderful. Well,
where to go from here?
Where to go from here? So we were just, while we were getting mic'd up, we were talking about what a squirrel perceives, and would we ever be able to perceive in the way that a squirrel does, among other things. So just hold on, and everything will be just fine. You're
Put
sitting
on your
in a
virtual
chair,
reality
maybe,
glasses.
and we're all present right now, in a way. So I want to begin by just asking each of you to say a few words on just the titles of your books. Metahuman and The Case Against Reality. What are you trying to indicate with these titles, and how do you want us to be thinking about kind of the scope of the topics that you're tackling with those titles? Deepak.
So, thank you, first of all. Thank you for having me, Mr. Chancellor. Meta means beyond, and human in this particular instance means beyond the human conditioned mind. So as soon as you're born, your mind starts to get conditioned through social constructs, economics, race, religion, history, and religion as well, and everything else, including science. So when we look at the world, we're looking at the world through our conditioning. What is behind of that is metahuman.
Thank you.
Thank you.
And Don, The Case Against Reality.
Case against reality. We all depend on our senses to keep us alive. When you drove here tonight, you used your visual system, and your life depended on it being right. not going through stop signs, not running into cars and so forth. And most of us think that the reason we can depend on our senses to keep us alive is because they're telling us the truth about an objective reality. And it turns out we can actually ask a specific technical question of evolution by natural selection. Does evolution by natural selection actually favor organisms that see reality as it is, or not? So that's a very technical question. We can use evolutionary game theory, and the answer is surprising. It turns out that organisms that see reality as it is go extinct when they compete against organisms that see none of reality and just have a virtual reality that tells them what they need to do to stay alive. And so that's going to be the idea, is that space and time and what we see with our senses is not the truth. It's a virtual reality that just gives you the minimal information you need to keep alive, and it hides the truth.
Love that. Well, thank you both. I mean, as we can all see, it might be said that Deepak and Don might have a little beef with reality. Can you guys kind of hear that? Maybe, just a little bit. So I'm going to play with you guys for a second on this. Deepak, in your book, Metahuman, one of the topics we tackle is realism. Tell me a little bit about realism and maybe outline some of the ideas of realism and tell us why, in your opinion, it's not tenable.
I think our current worldviews and even our science at the moment is based on what is called naive realism. So what is naive realism? Naive realism has two postulates. The first is that the physical world is exactly as perceived by the 5 human senses, which is obviously not true. We were speaking about the experience of an owl or a snake that navigates infrared, or a bat that experiences the world through the echo of ultrasound. Don has numerous examples of this in his talks. I was recently looking at the anatomy of the common butterfly called the painted lady. She hears the world through her wings, tastes the world through her legs, and smells the world through her antenna, has 30,000 lenses that move like a kaleidoscope. What is reality to that living organism? So naive realism, right now, all of our science is based that the physical world is exactly as perceived by the human senses, number one. And number two, the second postulate is that the physical world, as perceived by human senses, would still be there if no one was perceiving it. Well, how do you know? So that's naive realism.
Thank you, Deepak. And Don, in your book, A Case Against Reality, one of the things that you were just mentioning is about how we've evolved to not necessarily see the truth. And I believe in the book you reference fitness beats truth.
Right.
Can you elaborate a little bit more on evolutionary game theory and on how evolution fits into realism?
Right. So again, we tend to have the feeling that, of course, if someone sees the truth, they're going to be more fit than someone who doesn't see the truth. In some sense, perceptions that show you the truth will make you more fit. And the argument might be like this, that those of our ancestors who saw the world more accurately had a competitive advantage over those who saw it less accurately, and thus were more likely to pass on their genes, which coded for more accurate perceptions. And so after thousands of generations of that, we can be quite confident that we're the offspring of those who saw more accurately, and so we see more accurately. And so that sounds like a really intuitive result.
Sense.
It makes it absolutely, and many of my professional colleagues who haven't really studied this carefully just assume that that's true. But it turns out that evolution by natural selection in the last 30 or 40 years has been turned into a mathematically precise theory. A fellow named John Maynard Smith used game theory and evolution, put them together, and we have evolutionary game theory. And using the tools of evolutionary game theory, my graduate students and I first ran simulations to see what would happen. We had organisms that saw reality as it is, and those that we didn't let see reality, they were just tuned to the fitness payoffs. And the ones that saw reality just went extinct. They could never outcompete. And then I worked with a colleague, Chetan Prakash, who's a mathematician. I proposed a theorem, and he proved it. So it's actually a theorem of evolution, that if you see reality as it is, you cannot outcompete an organism of equal complexity that sees none of reality and is just tuned to the fitness payoffs.
Mind blown. I don't know about you guys, but this isn't real, so what's the point?
Well, I'm actually thinking, so it's a good thing that I can't see what's in front of my face, or I have no idea what's going on.
Well, just, Our senses tell us the earth is flat. Nobody believes that anymore. Your senses tell us that the ground you're standing on is stationary and you know it's spinning at dizzying speeds and hurtling through space at thousands of miles an hour. And that's convenient. I mean, if I could experience the dizzying speed and hurtling through space of this planet, I'd go extinct.
Right, that's right. And one thing that you could think of is that if you're writing an email and the icon for your email is blue and rectangular in the middle of your desktop, does that mean that in your computer there's something blue and rectangular in the middle of your computer? Of course not. Anybody who thought that misunderstands the whole point of an interface. It's there to hide the truth, which would be the circuits and software and so forth in your computer. And so that's what evolution has done. It's given us an interface that explicitly hides the truth and gives us eye candy that lets us do what we need to do. If you had to toggle voltages to send an email, your friends wouldn't hear from you.
But then can you each address, this experience, right? Here I am, and here is my hand, and I'm seeing this table, and I'm touching it, and I know it's there, right? Because this is kind of the common sense response to things in each of your books, which gets into questions about different kinds of realism again, but also the perceptual apparatus and what it does with us or against us.
So if you close your eyes and touch this table, all it is a sensation, period. Okay, the word table is the human construct for a collection or a confederation of perceptual activities. If you close your eyes, or anyone right now, the physical world disappears. There's no physical world. All you'll experience is mental activity. You might experience sensations, images, feelings, thoughts, and other perceptions, taste, smells, but none of them actually have a physical presence in the world. Now add visual perception to this, and voila, you have this. And you have this. Even your body is a perception. It's a perceptual activity. So if you just reframe the word object, because the word table is a human construct for the 5 perceptual activities. If you reframe that as experience before you call it an object, then reframe the experience as perceptual activity, and then you say, where is it happening? Obviously, it's happening in consciousness. Even the brain is a perceptual activity in consciousness. So when I activate what we call seeing, and Don is the expert on this, you actually construct the visual experience of the world, including the visual experience of your body. So seeing creates colors, shapes, and forms. Right. Hearing creates the experience of sound. And so where are these activities happening? You can say it's in the brain, but even the brain is actually understood by humans as a human construct for a particular collection of perceptual activities.
Well, on that note, Deepak, I would love to tie in one of the things you both, I think, touch on in some ways is this quantum physics aspect of the observer principle, which is kind of what we're talking about. By us merely observing the thing itself is shifting, the brain or the table, for example. Can you both tell us a little bit about how what we're even seeing can be measured from either a brain or consciousness standpoint, and both of your input on it?
Right, that's a great question, because it's one thing for a cognitive scientist and a spiritual leader to talk about the physical world isn't real. What do the physicists have to say about this? Surely they'll put us in our place. And it's quite interesting that what the physicists say, especially in the case of quantum mechanics. The question came up, and Einstein was really worried about this. It seemed that quantum mechanics was saying the moon isn't there when no one looks. And so Einstein actually asked, do you really believe the moon isn't there when no one looks? And Wolfgang Pauli said, Einstein's asking questions that no one can answer. Who could ever ask, as a scientist, answer that question, what exists when no one's looking? It turns out, surprisingly, you can do that. A guy named John Bell in 1963 proved a theorem. It is possible to test whether an atom or electron has a position or a momentum when no one looks. That turns out to be a scientific question that you can answer. And they did the experiment in 1984 and later, and it turns out that something called local realism, the idea that particles are real, they have real values of position and momentum when they're not observed, and that those particles' properties don't influence faster than the speed of light. That's local realism. It turns out local realism is provably false. We have experiments. So this is, the physicists are telling us local realism is false. It's not controversial anymore. That's the established. And the other thing that they've discovered is that non-contextual realism is false. So it's realism, the idea that particles have definite values of positional momentum, together with the claim that the values that they have don't depend on how you look at them, how you measure them. That's the non-contextual part. Non-contextual realism is also false. And then a very recent development is now physicists are saying something even deeper, that space-time itself is doomed. Now that's what they say. If you Google space-time is doomed, that's what they're saying. So you can actually Google it and you'll see videos where state-of-the-art advanced professors are giving you the reasons why space-time has had a good run. Ever since Newton, physics has been about what happens inside space and time. That's what it was about. Now they're saying, we don't know what physics is about because space-time isn't fundamental. There's something deeper and we don't yet know what it is. But whatever it is, it's very, very powerful and it predicts experiments and it has symmetries that you can't see in space and time.
Wow, thank you for that.
I think you're going further, though. You're saying that even atoms and particles don't exist.
That's right.
Right? So force fields, particles, atoms, once again, are human constructs for modes of human knowing and experience in consciousness. When you go to the Hadron Collider, you see this so-called Higgs particle. What you see is a ghost of something that's already happened, and what happened was a space-time event in consciousness.
And then Deepak, that begs the question of how should we be thinking about consciousness, which itself is a word for a construct that, as you explained, is one that we put into our bodies as soon as we imagine that we have a brain that's in a body that's
So
in an
as long
individuated
as we use words, then we are always talking in terms of constructs. You know, Rumi has a famous poem where he says, God's language is silence, everything else is poor translation. So, as soon as we say a word, we're already in the world of constructs. But the way consciousness is usually understood is it's the knowing element in every experience. What is it that knows experience? It's also, consciousness is that in which all experience occurs, is that in which all experience is known, but also that out of which all experience is constructed. Because visual experience is a construct in consciousness, as is any other sensory modality. So consciousness is, if I asked you, what is it that knows your experience of the body? What is it that knows your experience of the mind? Surely the fact that you can observe a thought means that you're not the thought. That you can observe an emotion, you're not the emotion. That you can observe an image in consciousness. And by the way, when you observe an image in consciousness, there's no picture in your brain of that image. Actually, none of what we experience as reality is happening in the brain. None of which. There's no sound in the brain, there are no colors in the brain, there are no textures in the brain, there are no tastes, there are no smells, there's electrochemical activity. And those neural correlates themselves are perceptual experiences in consciousness.
Right. I agree, and I'll also I'll add another scientific perspective. There's a field called psychophysics, which studies conscious experiences since 1860. It's been a scientific field. We use careful experiments and mathematical models, and the remarkable thing that comes out is that conscious experiences are highly structured. They're not just amorphous blobs. All conscious experiences can be described with great mathematical precision. And as a result, we can actually write down equations that predict when you're going to see particular 3D shapes, what 3D shapes you will see. And it's partly because we have such mathematical grasp of how consciousness works that we can create virtual reality systems. Why does VR work? You're putting on a headset, we're spraying light into your eyes, and you're being immersed in all sorts of amazing 3D. How did we do that? Because we know with mathematical precision how your consciousness works. And we know with mathematical precision the conscious experiences you're going to have. That's why we can create VR. So on the one hand, it is true, as Rumi says, in some sense the language of God is silence, all else is poor translation. And I would respect someone who said that, then says nothing further. Right, because then that would be entirely, and again, there are people who go into, I'm perfectly fine with that. But if we're going to say something about consciousness, then as a scientist, I say, let's say it with mathematical precision so that we know when we're wrong. And that's the whole point, is to be precise so we can find out precisely where we're wrong. But we're not always wrong, hopefully, and we can build VR systems with what we know so far. Although that doesn't mean that we're right. It just means that we have good technology.
Do both of you think we're getting closer or farther away from the truth as we learn more and we unravel all of this interesting theories, quantum physics, mathematics theories, neuroscience, any one of these? Are we getting closer or further? The more that we unravel it, it seems like there's more unraveling to be done.
I think we need a cross-disciplinary approach to understanding. If you stay only with the physicists or the biologists or the neuroscientists or the philosophers, then they all have their own perspective. But once you start having a dialogue between different disciplines, there is some clarity. For example, we were talking this earlier. I said, why don't we, and I thought of it in the spur of the moment while we were having this conversation. Instead of talking about quantum entanglement, we should be talking about qualia entanglement, because all experience is qualia. Everyone knows what the word qualia means. Qualia means quality of experience. So the color red is a qualia. The taste of wine is a qualia. This sensation is a qualia. If you want to put all experience in an acronym, it's sensations, which includes perceptions. All sensations are modified, all perceptions are modified sensations. Images, you have an image in your mind. Feelings, emotions, and thoughts. That's all of experience, and that's qualia. So if I think of my mother, just the thought of my mother, I see her image. I feel an emotion. I can even listen to her voice. And I can even smell her skin when I was sitting in her lap as a kid. Where is that happening? Where is that happening? And just the very thought, mother, can create all these experiences in consciousness. It's the same thing with this. As soon as you say table, you construct that experience, just the word, because the word is actually encapsulating all qualia. So you change one, you change all the others. You change your emotions, you change your thoughts. You change your thoughts, you change the perceptions. If you come to a cocktail party and I say, that guy Don Hoffman, he just won the Nobel Prize for neuroscience. And then the next person comes and I said, he's wanted by the mafia right now because they're looking for him. He helped them with their tax evasions. You'll see Don in two different ways. Because you're qualia entangled. Even your body is part of that experience.
Yeah, I agree, and I think it's a very deep question about, are we getting closer to reality in the sciences? It's a very, very deep question. One thing that most scientists would recognize is that we can never prove any of our scientific theories, right? You can't prove a theory to be true. What you can do is get evidence against your theory. And in some sense, the best approach to science is to try to be precise and then say what experiments and what outcomes of those experiments would show that you're wrong. But even if you predict something and it comes out as you predicted it in your experiment, it doesn't mean you're right. It just means you haven't been smart enough to figure out where you're wrong. And so that's one of the problems we have in science. I think it's a legitimate goal of science to try to come up with true theories. So I'm a scientific realist in the sense that I think we try to come up with true theories. But it's a weird situation where we can never know if we've done it. I personally think that the current scientific theories, general relativity, quantum field theory, evolution by natural selection, are incredibly beautiful, incredibly powerful, and they're all probably not deeply true. But my guess is that there are no scientific theories that are deeply true. But whatever deeper scientific theories we're going to come up with, they will have to give back general relativity, quantum field theory, and evolution by natural selection as special limiting cases. So the work that we've done isn't for nothing. It's going to be a boundary constraint on whatever deeper new scientific theories we come up with. And if we have a theory that says consciousness is fundamental, we will have to have a mathematically precise theory. And that deeper theory, for us to take it seriously as scientists, better give us back evolution by natural selection and physics as a limiting case when we project it into space-time, or we're wrong. So it's going to be a hard task to get a mathematical theory of consciousness that isn't wrong from the get-go.
But we must remember that science is an activity in consciousness, right? Scientific theories are conceived in consciousness, experiments are designed in consciousness, and observations are made in consciousness. So science is a particular activity in consciousness, in human consciousness, I would say that. And so if we can just figure out what the ontological primitive of the universe is. Current science, the ontological primitive of the universe is matter. But then you ask people, including Nobel laureates, which I've done with many of them, particle physicists, has anyone actually proved the existence of a substance called matter? And the answer is no. What is matter? Last time I spoke to Wilczek, he said we're still trying to figure out what matter is. But again, matter is a human description for a perceptual activity in consciousness. It's a human description. And if we can just understand that it's a very convenient fiction, matter is a convenient fiction. Without that, I can't go home, drive a car, take a jet plane. So, it's very practical.
Serves a purpose.
But is it the truth? It's very practical that the earth appears flat, that it does not spin in front of my eyes. But is it the truth? And why does it matter? In fact, our language is very interesting. When we think something is not important, we say, doesn't matter.
Right.
Because matter is
Right.
the ontological primitive. Now, if you replace that with consciousness, actually you solve the hard problem of consciousness. You've solved the hard problem of consciousness.
Right, and I'm on the same page. I think most of my colleagues are physicalists. So they would say that consciousness is not fundamental. So they would disagree with us. And they would, I think, rightfully point to the tremendous success of physicalist science over the last 300 or 400 years, right? Before Galileo and Newton, our technology was nowhere, our science was nowhere. With modern physicalist science, we've gone tremendous places, right? It is truly amazing. So they have a first-hand case to say, a physicalist framework has proved very, very powerful. But what happens is you always look at the edges where your theory is not working, where it's failing. And that's where you want to focus, because that's where you're going to get the new breakthroughs that can lead to new science. So just over 100 years ago, Lord Kelvin was telling young students that were very bright, don't go into physics, it's all done. There's a couple little problems on the horizon. There's Michelson-Morley experiment, we can't get that to work out. And there's black body radiation, we can't get that to work out, but don't worry about it, we'll mop that up. Well, Michelson-Morley led to special theory of relativity, and the black body radiation led to quantum mechanics. So those little blips on the horizon overthrew the reigning theory of Newton. And so that's what we need to do, is physicalism has been fabulous for 300 years. And I'm all for it, it's great. So we have to look, where are the edges where it's starting to fail? And one of them is space-time. We can't get space-time to work with quantum mechanics and special relativity. It turns out the very notion of space-time falls apart. It doesn't even exist at what they call the Planck scale. When you try to measure space-time at very, very small scales, you actually create a black hole and you destroy the very thing you're trying to look at. And if you try to look at it more closely, the black hole just gets bigger. So space-time as a concept literally has no operational definition below what's called the Planck scale. And then when you come to consciousness and its relationship to the human brain, this is the hard problem of consciousness. Many of my colleagues and I have been studying that problem as neuroscientists and so forth. we've been trying to get a physicalist theory that starts with neural activity, clean description, mathematical description of neural activity on the one hand, and then shows how conscious experiences like the taste of chocolate, the smell of garlic, and so forth, specific conscious experiences emerge from neural activity, and we cannot do it. We can actually show correlations. We can say, we can find, for example, I'll give you a concrete one. If I put a magnet, a TMS, so-called TMS unit, a transcranial magnetic stimulation unit, and touch it to your skull right about here, area V4, and inhibit area V4, you will immediately lose all color perception in the right part of the visual world. You'll just see shades of gray. You'll still see objects and motions, but all the color is gone. But the color is still here on the left side of the world. So it's right in the middle. It goes from colored to not colored. You turn the magnet off, and the color comes seeping back in. Or if I take the magnet and I stimulate V4, you get all these color phosphenes. It's like psychedelics without the drugs. and so we have all these correlations between neural activity and conscious experience, hundreds of them. That's not the question. The question is a scientific theory that explains how neural activity, which is sodium and potassium and calcium and other ions going back and forth through holes in neural membranes. How do you go from that to the smell of a rose, the taste of chocolate? Without a hand wave, we want a mathematically precise theory that starts with neural activity and gives us the taste of garlic on the other end. No hand wave. And also theories that say why that particular activity must be the taste of chocolate. It could not have been the taste of vanilla. Until we have that, we don't have a theory. And I can tell you flat out, we've been working on this for decades, and there's not a single scientific theory anywhere that can explain even one specific conscious experience. That's where we are. Now, that doesn't mean that we won't be able to do it. I'm saying Nobel Prize winners and really brilliant people, hundreds of them, have been working on this for many decades, and we can't explain even one conscious experience that may be telling us something.
Well, let's throw this back to Deepak then. Deepak, where does consciousness play into all this? Because in your book, Metahuman, you reference that consciousness is the fabric of our very existence. For people who might not have read your book or might not be familiar with this, can you elaborate a little bit about how consciousness plays into your perception of the world?
Consciousness modifies itself into experience. So when we are awake, that's a modified experience of consciousness. And we call this the physical world, the physical body. At night when you're dreaming, you don't have that experience. It's a different mode of consciousness, but you're experiencing images, feelings, thoughts, even stories, maybe jumbled up, but there is some experience. And then when you go into deep sleep, all experience disappears. Now, in the Eastern wisdom traditions, these are modified forms of consciousness, in the same way as ice and water and vapor are modified forms of water. So sleep state, dream state, waking state give us different experiences. The dream state, even now, if you close your eyes, you're in the dream state. That's what you're experiencing, mental state. You open your eyes, now this is a physical world, you're looking at this body as well. These are modifications of consciousness that modify themselves into perceptions and interpretations of perceptions, human interpretations of perceptions, that we call the physical world, the mental world, and the deep sleep, there's no world whatsoever. Now, in these wisdom traditions, there's a fourth state which pervades all these three states, waking, dreaming, and sleeping. Is called transcendental consciousness, and it is the one that is modifying itself into all experience. So right now, we can do a practical thing right now. I'm going to ask you a question. Please answer it to the best of your ability. Are you present here right now?
Maybe.
Can you be a little more enthusiastic, please? Are you present here right now? Yes. Okay. Now I'm going to ask the same question, and the answer is the same, but don't answer it till I raise my hand. Are you present here right now? Yes. So the question, are you present, is a thought. The answer, yes, is a thought. In between is consciousness. And consciousness without experience. You experienced it just now. It's the baseline consciousness that is modifying itself into thoughts, into perceptions, into feelings, into emotions, and they're all entangled. Qualia is not just the taste of red wine. This is a qualia, both the sound and the sensation. That's qualia. So when we look at, when we call something a quantum event, that's also a qualia experience. It's a modified form of consciousness.
I do have a question in listening to both of you dialogue here, that if we do get a little bit closer to truth, however we think about what truth is, then by Don's modeling, we go extinct. Yeah? So
Wow, Bill,
And
thanks
that
for
in
Discuss.
Eastern traditions is called liberation. In Eastern wisdom traditions, the stopping to identify with the perceptual activity and identifying with the source of perceptual activity is called freedom. The experience of something, how do you know anything exists? Anything. How do you know this exists, this exists, this exists, that exists? Well, because you're aware of it, right? Awareness defines experience of what we call existence. Now you say, where is this awareness? What is awareness experiencing right now? My awareness is experiencing this, all this, and what I'm thinking about all this. So where is this? Does it have a location? And according to Don Hoffman's theory of conscious agents, this and all this is a symbolic representation of conscious agents, and these conscious agents do not exist in space or time. And if they don't exist in space and time, they're not subject to birth and death or anything that we call experience. In fact, the body and the mind and the bottle and my shoes and this chair are symbolic representations of me, which is not in space-time. Right. Conscious agents are like the matrix that is projecting this world. Right. Have I stated that accurately?
Very, very well.
Okay.
Very well, yeah. It's like a big social network. So it's like the Twitterverse, right? So the idea is
and then there are leaky margins, because you can interact with your dog even though you don't know if the dog hears the same sound when you pronounce the dog's name, which you gave him anyway. But you have no idea what the dog is experiencing, but there's some communication that goes beyond species, even with plants these days. Trees communicate with each other. You know, when one tree is attacked by gypsy moth, it informs the other trees, I've got an infection.
I love, Deepak, this is a funny confession. I loved in your book where you said that there was a woman who is doing her thesis on communicating with birds. And Deepak said, can you tell me more about that? And she says, no, let me show you. And correct me if I'm wrong, Deepak, you said she took you outside and you sat down and a bird came and landed on her, correct?
Yeah, that's the story. Whether you believe it or not is different. But
I tried to make the Zoom, didn't work.
I did meet this woman at a Science of Consciousness, and she was a graduate student in Karolinska Institute. But Don gave me another example, those two people. Please give that example, which is even more dramatic.
Exactly.
Right. So there's two girls, Tatiana and Krista Hogan. They're conjoined twins. They were born conjoined at the skull. And they have two separate cerebral cortices, but they share something called the thalamus, which is a gateway from all the senses go through the thalamus to the cortex except for smell. And these two girls, they have separate brains except they share a thalamus. And it turns out that one girl can close her eyes and she can see through the eyes of the other girl and tell you what she's seeing. So most of us, we have what we call privacy of qualia, privacy of experiences. I mean, I believe that you have experiences, but for all you know, I could not have any experiences. I could be a zombie and I'm just making believe to you that I have experiences you would never know. So we can't actually get inside another person's head. But in the case of
can we, though? Can we share the example you gave us earlier, Deepak?
Right.
So recently I had the opportunity to meet a young boy who's autistic. He's on the autism spectrum. He has very poor mind-body coordination. And his mother called me and she said, he can read my thoughts. So I took our director of research, Paul Mills, who's a scientist, and I said, let's try and see if we can document this. So the kid, he has very poor brain-body coordination. So he is in front of a computer, but he has difficulty hitting the right key, but he finally gets it. Mother is behind somewhere there, and we give her a book to read. And we give her random sentences to read, and we give her numbers to read, and pictures to look at. And the kid is typing what she is reading. So finally, we went to the kid, and I said, Akhil, how do you do it? He's 12 years old. And he says, I love my mother so much that I can get into her consciousness, and then I see what she's saying.
Amazing.
But
Mic drop.
this is more dramatic.
Where do we go from there?
This is more dramatic. What your example is more dramatic, because it has a very good scientific explanation that you're giving right now. But I think if you look at kids on the autism spectrum, you'll find that they don't have the usual filters we have for constructs. So they don't edit perception the way you and I do. And you would know more about this, but even in medical school, I read about this experiment where if you bring kittens up in a room that has only horizontal stripes, they end up seeing only a horizontal world. If you bring up kittens in a room that has only vertical stripes, they see only a vertical world. And when you look at their brains, they don't have the connections between neurons to see a vertical world or a horizontal world. So that, even in medical school, I realized that we learn how to perceive. We are taught how to perceive. Now, how about other animals? There is a certain baseline perceptual activity which is species specific. But after that, we can even call it instinct. But after that, at least as far as humans are concerned, our perception is totally learned.
That's right.
Totally learned.
And I think this raises a couple of related questions, one for each of you. One of them is if we think about these sort of edge cases of the conjoined twins or the kid on the autism spectrum, or we think about the kitten or the butterfly. For you, Don, the question is how should science then proceed, right, to get at whatever we want to think of as the truth? Do we focus on these edge cases? Do we think about perceiving, doing a science from the butterfly's point of view? That's the one for you. And then the other for you, Deepak, is actually the related question of how should living proceed? Insofar as here we all are together in an intersubjective space that brings together our consciousnesses however we think about them. How should living proceed?
Let him answer the question.
Yeah, right. So in the case of Krista and Tatiana, that isn't as radical from the point of view of modern science as what Deepak is talking about with the autistic boy. Because there is a plausible story that we could try to tell about neural activity passing from one brain cortex to the other through the thalamus. Whereas in this case, it would be establishing that with experiments and getting it published in a scientific journal because it's been really verified in experiments would be a major revolution in science, because we don't have in standard physical science any way to handle that, whereas we can imagine a way with the example that I gave. So what we have to do, of course, is Deepak and Paul Mills have done a first experiment. What, as a scientist, we would want is to get several other teams of scientists in there, do very, very careful experiments on this, make absolutely, put them in as far away as we can, make sure there's absolutely no communication of any kind possible there, get Randy in there, the guy that debunks all these things, get him there and just really do it up. And if we can, all we need is one exception to the scientific rules, and then scientists have to pay attention. That's the way the game is played. So that's why we have to be very, very careful in these experiments
I think we need, though, in the scientific method, we need something that is not there right now. And the scientific method is right now based on a Cartesian split. Right? And we mention the observer, but we don't say what the observer is. And usually when you talk about the observer, people think that the observer is somewhat embodied somewhere here in the brain or here. But if you just shift that a little bit, that the body and the brain are not the container of awareness, they are an experience in awareness, because awareness by itself doesn't have a shape or a color or a form, it's not visible, therefore it must be infinite. Anything that is formless has to be infinite. And therefore, I would say there's no such thing as an embodied observer. The observer is experiencing mind, body, and this and all this all at the same time. They're entangled, these experiences, and the observer is non-local. It's a conscious agent, which is what Don is saying. And the matrix of conscious agents is interacting to create this experience. So how should science proceed? I think you can't have a classical observer and a quantum experiment. It doesn't work. You know, the classical observer, the observer is all, they're both the same system. The observer and observed are the same system, whatever you want to call it. Okay. So we need to revise. Our current science is based on subject-object split. Now and it's a good science, by the way. I mean, all our technology is based on this, so we can't discount it. We need to question, is there another way of doing science? And does that include, and it usually does, does that include contemplative self-inquiry? Okay. Does that include, if I ask you right now, close your eyes and experience your body. And all you're experiencing is sensations. Where is that experience happening? So, there are all these techniques: introspection, interoception, mindful awareness of thought, mindful awareness of body, mindful awareness of mental space, mindful awareness of the web of relationship, and ultimately awareness of awareness, or what is called metacognition, the ability to observe experience without judging it, but also to observe the observer in the midst of the experience, or to observe volition, because volition basically, and this is a question I actually had for Don, is motion, is locomotion a perceptual artifact? Or is it just a shifting of qualia? I mean, every time I move, I alter the space-time geometry of the entire universe. If I believe in the Planck scale space-time geometry, then I raise my hand, I've changed the whole universe.
Right.
Right? And who's the I that does it? Where is the I? It has no location. Because if it had a location, you would be able to see it.
Going back to the kid on the autism spectrum for a minute, right now, Liz Dahl and Melissa Terlonis are seeing through my eyes and wanting me to open it up for questions from the audience, because we're closing in on our time. And is there a mic? There's a mic there, and there's a hand right here.
I'll let you talk about the healing energy.
What?
Healing energies and so forth.
Yeah, see, energy as defined as you suggested it is not the scientific definition of energy. In science, energy is that which makes work possible. Mm-hmm. And energy and mass are together. What she's talking about is another paradigm of energy, which is called vital energy in wisdom traditions, or prana or chi. And there's a lot of interest in that kind of energy as a healing modality. But it's not the energy that scientists speak about.
Right, and I would say that science and spirituality have clearly had a tough relationship for a long time,
I was
right?
going to ask about that.
Since
Accidental adversaries.
right, I mean, since Galileo, right? I mean, the scientists will always point to Galileo. There, the spiritual tradition actually forced Galileo to recant, his views about the physical world. And ever since then, scientists have had this feeling like we're going to go away from spirituality. And they have. But now I think science has gotten to the point where we're ready now to start to ask questions about consciousness for the first time. And I think that both science and spirituality have something really important to offer now. The spiritual traditions, East and West, have studied consciousness for thousands of years. So clearly they have some insights from meditation, from their various kinds of practice. Clearly they have some insights. Science has an incredible methodology. The scientific method is absolutely incredible. It's non-dogmatic in the following sense. Individual scientists are, of course, human beings, and they're as dogmatic as anybody else on the planet. But as a social institution, what science does is it pits scientists against each other. I've got my theory, you've got your theory. I have to tell you what you could do to show my theory wrong. You tell me what would make your theory wrong. And as a result, we have a dialogue. And of course, I'm not trying to prove myself wrong, I'm trying to prove him wrong, and vice versa, right? But that, as a result, science is not dogmatic, it's precise and it's testable. So if we bring that from the sciences and the insights from the spiritual traditions, I think that we could evolve a scientific spirituality where we start to take these concepts that seem to have some real beef to them, some real meat, and turn them into precise concepts that we can actually make precise predictions from and make experimental predictions that we can go test. And of course, not everybody is going to be doing that. It'll be a small group of people who are doing that, but not everybody can build an iPhone. We can all use iPhones, but not all of us can build them. And that would be the idea, to have a scientific spirituality where we really forge ahead, bring the best of the techniques of scientific methodology, the insights from the spiritual traditions, and see where we can go in understanding consciousness, both personally and rigorously. And it's not either or now, it would be both and. And that's what I hope to see going forward.
Don, I had a question though on the scientific method. Heisenberg, and I'm paraphrasing right now because I don't remember the exact quote. You can look it up on Google or Wikipedia or whatever. But Heisenberg said, nature never reveals herself to us as she is, but as exposed to our methods of questioning. Now, I would say Heisenberg was a little off because we don't ask questions of nature, we ask questions of ourselves. Who or what is asking the question,
right?
Because the question actually determines how you're going to do the experiment.
Right.
And if you're designing your experiment based on questions, you have to know who or what is asking the question and of whom.
Right. So we will have to have a scientific theory of consciousness and of the self. What is this thing that we call the self? And is it necessary? Are there consciousnesses that have no selves? Can we get a mathematical model of consciousness that explains how that might be possible? What is a consciousness with a self? What's the difference there? So as a scientist, I would want to take all these ideas, which I think have a lot of intuitive appeal, and then see if we can't make them absolutely precise and make testable
predictions. And when you say
predictions.
the self is the same as a conscious agent, right?
I can imagine conscious agents that don't have a self. They have just awareness. In fact, I can imagine a conscious agent that, the mathematics that I've written down predicts that there are conscious agents without selves. And there are conscious agents that are aware with not anything specifically that they're aware of. They're just pure awareness without content. And then there are agents with content.
And everything that we perceive as physical is a symbolic representation
That's right.
of that consciousness.
Within consciousness, that's right, within consciousness. Right. That seems to be what the mathematics is proposing, absolutely. And one interesting thing that comes out of this is that the theory of conscious agents has different complexities of agents in terms of how many conscious experiences they might have. So you might have a conscious agent that has only 2 experiences possible. I call that a 1-bit conscious agent. But it turns out the mathematics says when they interact, they can create, if the conditions are right, they can create a new consciousness, a 2-bit. and then 4-bit, and then 8-bit. And so you could, eventually, the mathematics allows you to imagine building up dynamics of consciousnesses where you have an infinite conscious agent. So now we have, for the first time, a proposal for what we might call God, an infinite conscious agent, but it's mathematically precise. Now, it's probably wrong, but that's not the point. The point is, for the first time, to have a precise proposal for what we mean by God on the table, so that we can now precisely figure out why it's wrong, and then start to evolve it. That's how science works. I don't think we've had any true scientific theories yet. But science is a wonderful enterprise because we're precise and we figure out why we're wrong and we keep moving. And so I have a definition for God. Of course I'm wrong, but it's a definition. Now we can figure out why it's wrong and start to do something precise.
Brilliant.
Why don't we take one more question from the floor? And
I wanted an opportunity to show 1 or 2 pictures. Can I show them?
please,
Yeah.
while we're getting the mic
Right.
over to that side. And
The flower, pretty girl at the same time, birds. I put this because there's a poem of William Blake. It says, "We are led to believe a lie when we see with and not through the eye. That was born in a night to perish in a night, while the soul slept in beams of light." So when you look with the eyes of awareness, you realize that perception is a lie. And this last one I want to show you, or this is how a yogi would perceive reality, as physical, subtle, and infinite and non-local. But here's one slide that I thought would be very interesting. Please stare at the 4 dots without blinking in the middle of that figure. Keep staring without blinking. Now shift your gaze to the white background. You just produced that image. You projected that. That's how we create all visual experience.
I'll talk a little bit about AI. There's a real interesting question about AI. It used to be that AI had overpromised and underdelivered, and it went through a hard time for many, many years. In the last 5, 6 years, it's really started to come through with deep learning and so forth. We now have AI systems that are doing amazing things. They're still stupid in the following sense. They're very brittle. AIs can learn correlations. Deep learning learns correlations, but it can't learn causal models yet. It can see a rooster crow in the sunrise, a rooster crow in the sunrise. It gets that correlation, but it can't figure out which caused which, right? And we all know that the rooster crow doesn't cause the sunrise. But that was because we didn't have the mathematical model of causal reasoning until the last 20 years. But Judea Pearl at UCLA, again a UC campus professor, he and his team have come up with a mathematical model of causal reasoning. We're about to give that to AIs. When we give causal reasoning to AIs, and they already have the deep learning, they will start to run circles around us in original work like creative research. So the question then will become very, very pressing. Are they conscious? If this AI can beat you at everything, it can write poetry, it can write music, it can do research much better than any professor can do it.
Can it get frustrated? Can it have existential depression?
Right. We'll be able to program it so that it will actually act that way. So it's going to be really tough. It's going to be really tough for us. We're going to want psychologically, but the scientific question still holds, is it just a tin can that's faking it, or is it real? And we're going to have to deal with that. My own feeling is that we can't start with physical stuff and boot up consciousness. But if we start with consciousness, then we may have a different way of thinking about artificial intelligence. Your consciousness right now gives you portals into consciousness. When I look at Dean Maurer, I'm seeing just a face, skin, hair, and eyes, but I believe I'm getting a little portal into Dean Maurer's consciousness. I actually, whether he's paying attention or not, if you look at your own face in a mirror, right? Right. If he's bored, right? If you look at your own face in the mirror, you know firsthand that what you see in the mirror, just your face, is just skin, hair, and eyes. But behind that is the whole world of your conscious experiences, your love for music, your hopes, your fears, your aspirations. You can't see all that in the mirror, you just see skin, hair, and eyes. But nevertheless, your face is a portal into this realm of consciousness. And every face that you see is a portal into the realm of consciousness. So the question, we can turn the question around about AI and consciousness. It's not, could we take silicon and circuits and software, which are unconscious, and get them complicated enough to create consciousness? That's the classic question. I'm turning it around. The question is, if we understand consciousness and how it creates the physical world with mathematical precision, can we reverse engineer that and open up new portals into the realm of consciousness? And for what it's worth, I think we'll be able to do that. It'll be a very powerful technology, and I'm a little scared about what it could do.
And with VR, right now, there are applications that you can use VR to change your biology. Right. So you can have somebody with burns, and you can give them a VR experience that they're in snow, and it's effective treatment. You know, you can give VR experiences that will reduce inflammation, help people with anorexia, phobias, etc., because it is experience that is being metabolized as biology.
Right. Right. And you can also induce out-of-body experiences. So you have a camera from behind you looking at you from the back, and as you move, you see your avatar in front of you doing what you're doing. And pretty soon your consciousness leaps out of your body and into the avatar that you're seeing in front of you. So you can actually, you can induce an out-of-body experience that way, or you can take a TMS unit and touch it to the temporal-parietal junction on your right hemisphere, inhibit it, and you'll also have an out-of-body experience.
Don, I've wondered about the in-body experience, never mind the out-of-body experience. It's hard enough to explain how you get an experience of being in the body without being in it.
Right. It's a grand illusion.
It's a grand illusion.
I think with that, I'm afraid we'll have to close this part of the conversation. We have recorded this, and we'll be posting it online with an area for a discussion forum and for people to post questions to which our guests will respond to the extent that they're able. But I would like to invite you back into the lobby where there'll be a book signing. And also to please join me in thanking Don and Deepak for
Thank you very much.
Thank you.
And also, thank you again, Jennifer, for being here with me.
Thank you.
And thank you all, and we'll see you out in the lobby. Thanks again.